We're a homeschooling family, and since I'm the mechanic engineering type, I take a lot of the math. And as an adult, I have grown to really appreciate math, and I did not appreciate it as a child and student. And I think a big part of that reason is because it wasn't clear to me where I was going to be using math in the world. And as an adult, I've learned that math is like a cheat code or a shortcut, where it allows you to get information that you couldn't otherwise get without a lot of work through calculations. So I want my children to have that same experience while they're young and see the value in math. And one of the projects I remember doing in school was this, basically, where you take a paper protractor and you look through a drinking straw and you measure the angle. And so for our upcoming trip, where we're going to see the world's tallest trees and cliffs, I thought it would be fun to do this with the kids. So I made this clinometer out of the protractor that I used in 6th grade and some brass tubing. And since I had a lathe, I made a fancy little plumb bob to go on it. And then I just took some rope and made knots every 12 inches. And in this case, it's a 30-foot rope. And I just did a test. I measured the peak of my house up there, and from the tip to my eyes was 13 feet. And so you always have to remember your own height that you hold this at when you're taking the measurement. So then I sighted the tip like that, and then held in place the string, and I got 67 degrees. What you have to remember is that when this is perfectly horizontal, it's 0 degrees, and yet your protractor says it's 90 because of the way protractors are used. So as you tilt this, you have to always take your measurement and subtract it from 90 in order to get your real angle. Now you may notice that my string is not hanging from the dead center of this hole because there used to be a little bar there, but I was really surprised at the accuracy. So what you do, you take your 67 degrees and you subtract it from 90, so you get 23. So you do 23 tan. That gives you a little tiny number, and then you multiply that by how far away you were, which was 30 feet, times 30 feet, and I get 12.7 feet. So that's from my eyes to the tip. So that number, in theory, should be 13. Of course, there's measurement inaccuracies. There's basically, if the height of the ground changes at all, that affects it. If the rope stretches at all, because you can stretch rope as you pull on it, that changes. The measurement that I made with my tape measure, and your ability to very precisely see which degree marking you're at, and the fact that this doesn't swing from center. So there's lots of measurement inaccuracies, and yet we got 12.7 instead of 13 feet. So yeah, I just thought that was kind of a cool thing. I'm hoping my kids will enjoy it. And if we're really far away from things like Half Dome or El Capitan, then instead of using a piece of string, which would take forever, we'll probably use GPS. But yeah, there are tools you can buy that do this for you automatically, but I thought it would be great for the children to see how a very simple tool and just some string, and you can make calculations that are fairly accurate. So yeah, I hope that inspires somebody, and teach your kids all that you can. Enjoy the time that you have with them, because boy, oh boy, does it fly by.